So let's practice some problems from this worksheet on implicit differentiation and logarithmic differentiation. All right, so we want to find the derivative of the function y with respect to x. So starting with this problem here, we see that obviously y is defined implicitly, so we're going to have to use a technique of implicit differentiation. So I'm going to take the derivative of each side with respect to x. All right, so on the left-hand side there, the first thing I notice is when I come to the x cubed, y cubed, that's a product. So I'm going to have to use a product rule. So the derivative of the first is 3x squared times the second as it is, y cubed, plus the first as it is, x cubed, and then the derivative of y cubed. Now that's 3y squared dy dx. Minus, so that was the whole, those two terms are coming out of the derivative of x cubed, y cubed. Now I have minus, the derivative of y is just dy dx. And on the right hand side, the derivative of x is 1. So most of the hard work is done at this point. So I just want to solve for dy dx. So I'm going to look for the terms that have dy dx. And I'm going to keep them on the left, move everything else to the right. So I have, if I clean up that what's in front of the first dy dx, that's 3x cubed y squared dy dx minus dy dx equals 1 minus 3x squared y cubed. All right, so now I'm going to factor out dy dx from the left. Oops. So I get 3x cubed y squared minus 1. I'll leave the right-hand side as it is for now. And then I'm just going to divide this stuff over to the right-hand side so that I solve for dy dx. So I get 1 minus 3x squared y cubed over 3x cubed y squared minus 1. And there's my derivative. All right, on to the next one. So y equals sine of xy. Again, we're going to need implicit. So we're going to do the derivative with respect to x of both sides. Okay, on the left-hand side, that's just simply the derivative of y, which is dy dx. On the right-hand side, notice we have a chain rule here. We have sine of something. Okay, so that says that the derivative should be cosine of the something. And then I have to multiply by the chain rule factor. In other words, the derivative of xy. All right, but that's a product. So I'm going to get a product rule. Derivative of the first is 1 times the second as it is, y, plus first as it is, x, derivative of the second, dy dx. All right, so there is my differentiation step. Now I really just need to isolate dy dx. So let me multiply the right-hand side out. So y cosine of xy plus x cosine of xy dy dx. As usual, I just want to get dy dx isolated, so I'll bring that to the left-hand side. So I have dy dx minus x cosine xy dy dx equals y cosine of xy. I'll factor out dy dx on the left. And finally, I will divide this whole term to the right-hand side. And there we go. There's our derivative. All right, on to logarithmic differentiation. So in this first one here, it just looks a little complicated. I wouldn't have to use logarithmic differentiation here, but I'm going to because I think it's going to make it easier. The first thing I'm going to do is I'm actually going to rewrite this as x minus 1 times x minus 2 times x minus 3 all to the 1/2. All right, so then if I do logarithms of both sides, ln y is ln of this whole right side okay, and now I can do my simplification using the algebraic logarithm rules. So ln y is 1/2 ln x minus 1, x minus 2, x minus 3. So that was bringing the exponent down. Now, on the right-hand side here, I have ln of a product of 3 things. So that's not too bad. I'll just do 1/2. It'll be ln of x minus 1 plus ln of x minus 2 plus ln of x minus 3. Now I have it broken down as much as I can from the logarithm rules. Now I'll take my derivative. So now I'm just going to do the derivative of both sides. So this is just what was above. I'm not going to write it out again. So on the left-hand side, remember this is implicit now, I get 1 over y dy dx equals, all right, now if I go back and I look what I had previously, I would get a 1/2 as a multiplicative factor, and then I'm going to take the derivative, ln x minus 1, which is 1 over x minus 1, and then plus the derivative of ln x minus 2, which is 1 over x minus 2, and then the derivative of ln x minus 3, which is 1 over x minus 3. And in my final step, I'll do 2 things at once. I'm going to multiply the y over, and I'm also going to replace it with what y is from the beginning of the problem. So dy dx would then be the square root of x minus 1, x minus 2, x minus 3. And then I have a 1/2, so I'll put all that over 2, and then what was still inside. Done. Okay, so let's look at B here. Now this one is great for logarithmic differentiation because I need to do it here. I have a function of x, just x, raised to another function of x, ln of x. So let me just rewrite that. So now I'm going to apply logarithms to both sides. That would be ln y equals ln of x to the ln x. But realize on the right-hand side, ln of x is the exponent there, so that can come out in front. And what I actually get is the quantity ln x squared. So now I'm going to do my differentiation. So I do the derivative of the left-hand side equal the derivative of the right-hand side. All right, now notice, again, I have an implicit on the left here, so 1 over y dy dx. But on the right-hand side, what do I have? On the outermost, I have something squared. So it's going to be 2 ln x then to the 1 power times the derivative of ln x, which is 1 over x. So I get 1 over y dy dx equals 2 ln x over x. And I do my final step, which is to bring the y over and replace it. So I get x to the ln x times 2 ln x over x. Okay, and so that's one way I could write that. Done.